Thanks for the kind introduction. Let me go ahead with the presentation. And to do that, give me just a minute. Let me share my screen. Let me see. I see my screen. I'm having some technical difficulties, it appears to be. So, can you guys see my screen? Is it okay, everybody? The problem is I cannot hear the responses. That's the problem that.
We can see your slides, sir.
Oh, you can? Okay, thanks for that. Okay. So first, good morning. Hope you all are doing well. Cold and the cough, so please pardon my disruptions. Before I start, I'd like to thank the committee for inviting me to present the topic. IT project and program management, it's in a very extensive area. And due to short durations, what I'm going to do is that I'll cover very high level. And then at the end, we'll have some 5 minutes of Q&A. I know the lot of speakers, who are waiting to present their topic. Going to the next slide. Okay. Let me get the laser pointer. So there are a couple of slides. What I'll do initially is that first we'll define what is, and after we define the project, we'll see what are the 4 stages of a project. So there are initiation, planning, budgeting, and high-level milestones, project execution, project closure, and the program management. And then we'll for Q&A. And I know that most of the audience, the students. So once you graduate, you may not be able to be a project manager right away. But of course, you're going to work in the environment that will be in a project, and then audit can within a program management. First, let's define the project. So usually, a project is a set of tasks which has a set of goals. And the key thing is that it has a defined timeline, and it is always delivered by a project team. And as a head of the initiation, you will have a role called a project manager. And this individual who oversees the planning, scheduling, tracking for the successful completion of the project. Okay, going to the next one. So the stages that if we look into the project, the first, is initiation that we looked into planning, execution, warranty, and closure. And as you can see that there is a circular relationship between all the 4 stages. And this initiation, where we start the project, this is actually a business-driven initiative because investment and the business needs, business decides that which project to start, and they actually fund the project. So this is where the input that happens, and once a project is initiated, it goes through the planning, execution, and then the warranty and the closure. Going to next slide. For the initiation, right, when the initiation happens, what are the different tasks that occur in the initiation phase? So first one is that ROI and business roadmap, a high level scope, a rough order of magnitude, which is the costing, and the stakeholder and business team assignment. Because every project has to deliver certain, functionality, which must do some impact to the business process. Because IT does not exist in its own space. It usually supports the business process, and usually when a business means that it supports the end users or the customers. So for that to happen, we have to know what the scope is. And at the time when we initiate the project, we do not understand the whole scope. Rather, we do like high level scope. And based on that, we try to define what would be the cost of this project. And then, based on the cost of the project, we also assign the stakeholder who is actually owns the project. And then we also have the business team assignment who actually, owns the functionality of the project. Going to the next slide. Once the initiation phase is done, we know how much it's going to cost the function to deliver. Then comes the planning and the delivery. In the planning phase, right, what happens that the team goes to the detail level scope, what exactly that we need to deliver. And then at that time, we also have the high level roles in the project, such as project manager, team leads, architects. Uh, and also, we do a bit more project estimate at the time from the ROM, and we get the approval. Also, at the same time, we also develop a charter, project charter, or we do like a statement of work for the vendor. If sometime, often you will see that when you work in a company, you're going to have some vendor to deliver certain aspects of the work. So you have the SOW for the vendor. SOW means statement of work. So you tell the vendor, hey, these are the things that I want. And the vendor is going to say, well, for this, I'm going to charge you this much. And then, and based on that, scope and the costing, and also vendor will give you the schedule that how they're going to deliver the project at what time frame, and also some legal, agreement between your company, and the vendor company. And they also provide the project scheduling. So once we have the planning kind of done, so we are kind of getting to execute the project. So at that point in time, when the execution, we start to execute, then we have a very detailed documentation of the project. And that documentation usually tells what exactly is needed by the project, by the business, because business actually signs off on the requirements. So this detailed documentation is a requirement which is agreed by business. And at the same time, based on the scope, the project team along project manager or the lead takes care of the detailed scheduling based on the scope and the project delivery methodology. Because I think that, when you work in IT, you will know that there are different methodologies been used to deliver the project. You can have waterfall, agile, a product team. And nowadays, for like last 10, 15 years, waterfall is kind of going down and agile is coming up. And product team is another version of the agile where you have the more, team that is, delivering or taking care of a certain application. Once you have the digital scheduling done based on the delivery methodology, there is a regular weekly team meeting, that happens multiple times a week. And also we have the project governance, which includes, scheduling, budgeting, risk and issues that's been taken care of on a weekly basis. And at the same time, these all four steps, they're mainly on the admin side, where you put the team together, you know the work, And this is exactly where the design development unit tests sit. Excuse me. Uh, the design development unit test, system test, user acceptance test. These were actually the developers comes into picture, architects, developers, and they work on the same methodology that we used for the scheduling. They work on the same methodology to deliver the functionalities based on the business requirement. And once the product is developed and tested, and users are happy about the product, yep, this is exactly what we stated in the documentation, and this is what it does. The business approves, and we migrate the codes to production. And this part, the design development, this where, as I mentioned before, the developers comes into picture, and this is exactly where we deliver the key functionality or the software has been created or crafted at this point in time. And once business approves, we are ready to migrate the code into production. And then once we migrate the code into production, then what's the next step is the closure of the project, right? So so once we move the code to production, we have to deploy the production code, what went in, right? And if the code is working as expected. And usually for a bigger projects, once you move the code to production, you have a war room kind of where all the key stakeholders they meet either every day in a week, given the seriousness of the project, or excuse me, the number of issues that's being raised in a given project. And sometimes, I have worked in a war room where, it's a continuous, right? So you don't break, you go for, days, because you have multiple leads, they come in, take over like 8 hour shift, just to make sure that, software is developed and deploy it to make sure that, they kind of work without any issues for the users. And then comes the issues, fixes, validation, and anything that, for example, we did migrate a bunch of code. We have some issues. Then we have to run a change of the code. We have to test it, validate it, and we're going to do the migration, within that window. And once all those things are done in a cyclical order, then we get a final business sign off saying that, hey, this is the project we had, and this was delivered. And at the given time, once the functionality has been delivered, the project is closed with budgeting and lessons learned. And then also at this time, team is also disbanded from the project, which officially concludes the project. And I mentioned over here agile ceremonies over here that you can see. Lessons learned at the end of the project closure is a part of the waterfall methodology. But when we do, let's see if I go back over here. So here you see the design development, unit test, sit, UAT. We also have agile methodologies. So they have something called like in ceremonies, agile ceremonies, where they have the retrospective, where when the work is sprint, like 2 weeks, 3 weeks, given different agile methodology, so the framework. So every 2 3 weeks they run the sprint, develop the code, and they learn what exactly they could improve. So that lesson learned in case of agile is being implemented or take care of into subsequent sprints. In that way, agile is more efficient to take care of the errors that happen in the last sprint versus the new sprint. And one thing I forgot to mention is that in case in the execution phase, I have the issues and risk as highlighted. So what happened that usually when we talk about a project manager, right, we usually think that, well, that guy is doing the scheduling, budgeting, other things, right? The key object or the aspect of PM or the project manager is to monitor the issues and risk, because these two actually impacts the project so much, because they can take down the scheduling, budgeting, and the quality of work. So a project manager must be focused on looking into the risk and issues and should take all the precaution he needs to make sure that the risks are minimized and issues are tracked and resolved in a very timely manner. Now that we have gone through the project, life cycle, the four stages, uh, le- now let's talk about the program management. I have only two slides. I'm not take that much time. So for program management, right, usually what happens is that a program is something, it's like a group of projects, right, which deliver a key objective. If I want to do an ERP implementation, for example, right, which is a big piece of software, right? In that way, I have multiple smaller projects. And then uh, we then just when we group all of them, oversee multiple project, we do as a program because it adds a lot of value to that one. So that in that way we can track the whole program level scheduling, budgeting, issues and risk at the very program level, high level. And if we look into the program management, hierarchy with respect to the projects. So let's say for level one, we have program, right? Level two, we have project one, project two. And the level three, project one might have another two sub-projects. So that's the way you have the program level, you have the hierarchy, but in project, it's like independent. It has its own team schedule budgeting. The program level, we kind of, merge everything, roll up everything at the top. So with that, I kind of concluding my presentation. I know I don't have much more time. So any Q&A questions or questions, anybody from the audience?
Audience, do you have any questions? You should ask a question. As you can see, Sar has 25 years of experience for leading a project management. They are undergrad students, uh, so I think they don't understand how to ask a question. You should ask. Sir, I have a question.
Yeah, go ahead, please. Yeah.
From our students. What are the different challenges a developer has to face in each stage while developing a project actually? What are the major challenges?
Well, one of the key things that, in a project, right? I think that the challenges that happen between the requirement and the delivery or the coding of the, other program, right? It's very important to understand what the requirement or the business is asking for. But one thing is that even before the developer gets into coding, depending on the team hierarchy, you might have a business analyst who looks into the business requirement and translate that for the developer into understandable, documentation. So that handover needs to happen between business analyst and the developer. Which way the developer understands what he's coding and how it's going to impact the user. And another thing that I will tell that, I know that, the programmers here will be studying the career as a developer. Uh, Usually in a company, you have two tracks of, software development. Okay. Right now with the DevOps model and the Agile, things are getting a bit kind of mixed together. But you will see that in your, in a career, one is usually that when you put the new code into production. And the other track is that when you support that code for the users in production, or in other way, you can call it production maintenance. When you do production maintenance, you will get in touch with the user. And only at that time you understand actually wants. And what I would say that usually based on a developer, I have been, I did a development in a system architect for a long time. What I can tell that as a developer, we might think that, hey, these things looks pretty easy. This is how the user will work on it. But when you talk to the user, you will see that his understanding or her understanding is totally different from your understanding. And that interaction with the end user, when you do support of a certain application, it will give you a different aspect of how to develop and deliver software. It's a whole new experience, and you will learn by yourself, right? Because every project, every software, every user base has its own nuances, right? Has its own, domain that you work with. So that's something to keep an eye on. That when you go for project delivery, try to work on the support and try to talk to the user. In that way, you will know what they want and how you can help them to achieve their goals. So that's one of the key is that as a developer, that one of the challenges thing to understand the user mindset.
Right, sir. Uh, I have another question. As an industry expert, what are the basic courses should we give importance in CSE syllabus?
Well, I'm not an academic per se, and again, what I would say is that, before getting
Like,
the,
sir, before applying a job, what are the basic courses a student should learn deeply or have a clear conscience conception courses? As an industry expert, what is your suggestion, sir?
yeah, I think that, because, usually, one of the things that, the US markets, the way it works is quite different than, Bangladesh markets, right? And IT is quite different, right? It's always a software driven, right? So anybody who wants to get into certain software development, certain tools, he needs to be an expert on that particular tools because IT per se is an application, right? So either you know or you don't know. If you know that there is a way to enhance your skill set, right? So whatever, a tool that anyone wants to work with, he needs to be an expert on that tool. And as the, market changes often, he, he needs to be kind of get updated on different versions of the tool. Other application that's coming up and sunsetting the application that he's dealing with. And when a student goes out for a job, I would say that, maybe, from the university aspect, kind of have some kind of, market or the industry review kind of a board to see what's happening currently in the market, what the demands are, and based on that, give the students kind of, different, tools to learn. Hey, these are things that are happening. You guys can work on it. Uh, and at the same time, teach them the methodologies, of software development, the project management, if they want to get into all those areas. So in that way, they're kind of, they know the base, and once you know the base, you can always work on it. So that's my idea, so nothing more.
Sir, I know you are a very busy person and you are in a different time zone. So thank
That's
you
right. Yeah.
so much for giving us your valuable time. So we hope to see you in next conference, I hope. So please come to Bangladesh one and visit Varendra University whenever you get time.
Yeah, I
So,
do.
sir.
Yeah, I do appreciate the, the call to kind of talk. And this may just I'm not sure, I've been to Varendra like 6 or 7 years back and did like an on-site kind of lecture for an hour or something. But I do have a touch with Varendra for a while, and actually I'm based from Russia here, so I've been there, at university. So thanks again.
Thank you so much, sir. Please give him a round of applause. Thank you for your
Okay,
presentation.
thanks everybody. Good night. Bye bye now.
Moving forward to the industrial talk session, I now welcome Mrs. Nazmi Mohsina.
Hello, Assalamu alaikum, greetings. This is Nazmi from.
Nazmi Mohsina is the Global Technical Director for AMCA International, where she leads the development, governance, and implementation of technical requirements supporting global product testing and certification programs for the air movement and control industry. Her work focuses on ensuring technical rigor, consistency, and integrity process, standards application, and laboratory operational worldwide. Ms. Mohsina brings a strong engineering background to her leadership role. She holds a bachelor degree in electrical and electronic engineering from the Bangladesh University of Engineering and Technology and master's degree in electrical engineering from the University of Dayton. To further enhance her effectiveness in technical governance and organizational leadership, she completed a technical leadership certificate from the University of Wisconsin-Madison. So her contribution to advancing technical excellence and leadership within the HVAC and building system industry have been recognized by her peers. In 2020, she was named to Engineered System Magazine's 20 to Watch Women in HVAC list, acknowledging her influence and impact in a highly technical field. Welcome, ma'am, to our UCICS 2026, the second session. You may start your presentation.
Thank you. Thank you for the introduction. Assalamu alaikum, greetings. Thank you for inviting. I really appreciate it. Okay. In a rapidly evolving digital world, success in computer science demands more than technical skill. It requires strategic thinking, creative courage, and resilience. Let's think smart, build boldly, and view innovation as a process shaped by experimentation, learning from failure. By embracing challenges with confidence, we can move beyond limitation and create solutions that leave a lasting impact. So, I'm a typical boring engineer. I don't know jokes, so I'll start with a quote. The future belongs to those who learn more skills, and combine them in a creative way. So let's look at why are we here. Sometimes life can be bigger than algorithm, data structure, or the next project deadline. Let's talk about how we show up, how we think, act, rise in the face of uncertainty. In a world that's advancing faster every day, success in computer science is not just about technical knowledge, know-how. It's about finding the right balance. A balance between analytical rigor, creative ambition, and unshakable resilience. But what does that balance really look? So that's what we're going to look today. And how do we make it real in our lives? The world is changing so fast. Technology changes career faster than the degrees, right? So technology also creating the opportunity. The overall, what it matters is the mindset, how we look at different problem. So first, let's look at think smart. Your parents may have said it many times. To innovate, we have to think smart. It's not work hard, right? You have to work or think smart. It's not just fast or hard, but you have to address anything strategically. Think about why does this problem, you're in a project and there's a problem happen. Why does this problem matters? What assumptions are baked into this challenge? What are the simplest, cleanest path forward? Being smart is not that you are memorizing the solutions. It's in learning how to think deeply and adapt with intention. Smart thinkers understand that clarity comes before complexity, and they're asking the right question. Don't be like shy to ask question. I also came from Bangladesh, so I had that fear of asking question. Oh my God, if I ask this question, will the people think I don't know it, or maybe is it a stupid question or whatever, right? So encourage curiosity over fear of being wrong. The smartest people, they ask questions. So always remember, strong roots create tall trees. Next, build bold. Smart thinking alone is not enough. So I can think all day long. But what it needs action. Boldness is where the action lives. Building bold means turning your ideas into prototype. Starting even when you are not unsure, you don't know what's this idea gonna go or not. Exploring before you feel that it's gonna be fully prepared. Bold builders are not fearless. Look at Elon Musk, Steve Jobs, and others. They are courageous in spite of fear. They don't wait for perfect condition. They create in uncertainty. Common execution is rare. Start before you're ready. Your first vision is allowed to be bad. That's completely fine. Many projects you are right now are working has been improved over time, isn't it? So that your passion, your work is gonna take you to the finish line. So create the momentum and don't hold on the perfection. Especially I'm talking with the female students over there. I'm one of them. So we always look into the perfection. So let's just get going, get the ball rolling. And always remember, get out of the comfort zone. When you are in the comfort zone, and I'm also talking to myself as well, comfort kills ambition. You are really comfortable. Okay, life is so going well. Challenge yourself. Action builds confidence. So normalize your fear. Everyone feels it, but successful people actually act anyway. So whenever you act something and you get it complete, that confidence comes after your action. Remember, step outside the comfort zone. Next is innovation. As an innovator, you have a permission to test. You have a permission to experiment. And yes, you have permission to fail. You are not willing to risk the usual. You will have to settle for the ordinary. Someone else's success does not reduce yours. Sometimes we think my friend is doing well. It doesn't mean that you're going to do that good. Equal to improvement. Small change matter. Problems come first, break the myth, and innovation does not require a big invention. Take a small step at a time. Improve the existing system. You don't have to solve a problem in somewhere else. Start from your own area. Reinforce practical creativity. So all we have been talking about taking different steps, right? But what happened? Things fail. Things doesn't go the way you want to go. So reframe your failure. Let's talk about failure. Because it is not just a possibility, it is a certainty on land. You will fall short of your own expert. You learn that does not work. There's a valuable information you learn from it. Without that, you cannot iterate, refine, and improve. Without failure, there is no progress. So if you look at the real innovation story from different scientists, let's pick Thomas Edison. It's a long road of creating the light bulb to the countless products that pivoted before finding the success. We see the truth. Failure is a part of the path, not the opposite of success. Learn, adapt, let happen. Ask, why did it fail? What did this teach me? That mindset shifts transfer from frustration into fuel. If it pushes you to deep digger and get creative and try again and smarter eventually. The heart of innovation, a disciplined yet imaginative process where you constantly refine your thinking through action, reflection, iteration. You are not falling every now. If you are not falling every now and then, that means what? You are not trying, right? So failure will be part of life. Adapt it, accept it, and move on. Okay. So then soar beyond, limit your journey. So we live in right now, the whole world is on your hand. Look, I'm from Chicago. So Mustafa, he was from Michigan. I don't know, the next speaker is going to be somewhere else, but we are all in a one room. So beyond the world we are living right now, everything is in our hand. Thinking smart, building bold, learning from failure, cultivate something very powerful. What is it? Resilience. Resilience is not merely surviving setbacks. It's about using them and become better. That becoming more capable, more innovative versions of yourself. It's about transforming obstacle into opportunity. Confidence grow through the effort, skill sets create freedom, and growth compounds. Small wins that builds your belief in yourself. Don't compare your journey with others. Keep your own pace. Encourage patience and self-belief. So let's wrap up what we said today. Your contribution matters. You are not just a student in a major. You are the future creator of the technologies that will shape society. I guarantee you that. God willing, the world needs thinkers you can analyze with depth, builders who take bold risk, innovators who see beyond fear. So think with intention, build with conviction, and learn from your failure, and soar beyond anything you once thought possible. Success, going from failure to failure with a loss of enthusiasm. Every atom gets you close to be the breakthrough. And I'm waiting for the day, for that day when I'll see many of you succeed in this life. Thank you. Any question?
Very nice presentation. It was very motivating. So dear audience, do you have any question? No? This session was especially helpful for you, especially the students. You should ask a question. Okay, ma'am. On behalf of our students, I will ask some questions. So, how early should students start thinking strategically about their careers, and what does strategic thinking mean at the student level?
Thank you. Very good question. So as I mentioned, the world is on our hand, right? So you are undergrad student or graduate student, for example. So next step, think about the next step. You want to come to USA for your master's or graduate school or anywhere. There are so many Bangladeshi over here. You have a school picked up and then see who are the Bangladeshi professors there. Reach out to them. So people who are like we are living outside Bangladesh, we are there to help you guys, right? So reach out to us, network, think strategical, and then ask them what you need to do to come here. If you are doing some, I'm not saying that everybody have to leave Bangladesh and follow us. I'm not saying that. Also, for example, you are doing a job, similar job is getting done a different country. Ask them how they are doing it, learn from it. So strategic network.
Okay. So sometimes many students associate innovation with breakthrough ideas. How can small incremental improvements also be powerful forms of innovation?
That's another good question. I believe if you wish to do something, you have some internal passion, you will be succeed. So reach out to your professor or maybe ask for outside help. So I'm a Buet alumni. From here, we are doing some work at Buet. But again, it doesn't have to be Buet. It could be any other university. So if you need some kind of any additional assistance from any other alumni or any other Bangladeshi folks, it doesn't need to be Bangladeshi. It could be anybody else, right? We get foreign fund. So reach out to the folks and then contact the professor, contact the industry expert, and explain them what you need and why you need it. So that they can provide you the support that is needed.
Right. So could you please share a real-world example where experimentation led to unexpected but valuable outcomes?
It happened in my personal life as well. Okay. Yeah. So yeah, the thing is, like, as you have seen, I did my all paperwork is electrical, but I do something different, right? So again, you just keep like sometimes that you will see the roadblock and you just have to cover that roadblock and try to find out what's the best out of it, right? So that's what I'm gonna suggest. Just keep pushing your limit.
Thank you so much, ma'am. That was a
You're
very
welcome.
answer. And we are really proud to have you here.
Same here.
We
Nice to
were
see
from
you.
different time zone. Thank you for
No worries.
your valuable time. So we hope to see you in person whenever you come to Bangladesh.
Inshallah. Thank you for the invitation. And to come to Chicago, let me know. Thank you.
Okay, thank you. Please give her a big round of applause. Moving forward to the next industrial talk by Dr. Abdul Ali. His title is Designing ROC Networks for AI Workloads. Welcome, sir. Dr. Abdul Alim is a staff research scientist at the IBM Thomas J. Watson Research Center in Yorktown Heights, New York. He works on the design and implementation of high-performance networks for AI structures. Prior to this role, he contributed to IBM Cloud, where he designed and implemented virtual network functions such as network load balancers and various network services for the IBM Cloud platform. Dr. Alim graduated from the University of Rajshahi in Bangladesh, earning a bachelor's degree in computer science in 1999 and a master's degree in computer science in 2001. He later completed a second master's degree in computer science from the University of Northern British Columbia, Canada in 2007, followed by a PhD in computer science from University of Cambridge, UK in 2011. After completing his PhD, he worked as a postdoctoral researcher at the University of Lancaster, UK, and subsequently at Imperial College London, UK. A very big welcome to our session. You may start your presentation. Thank you.
Thank you. Can you hear me and see my screen?
Yes, sir. We can see your screen.
Thank you. So thank you for the nice introduction and invitation. So I'll be talking about the designing a ROCKY network. This is RDMA over Converged Ethernet networks for AI workloads. So it's a joint work by a network team at IBM Research in Yorktown Heights and Haifa, Israel. So I'll give the motivation of the talk, like why do we need a new network design for the AI workloads. Then I'll present some of the design options that we have to design new network for specifically for AI workloads in the cloud settings. And what are the options? What are the challenges for this AI networking? Then I will cover some approaches that hardware approaches that to resolve these issues that we face now. And then I'll present some our innovative software approaches so that we can resolve these networking issues in these modern AI networks. Finally, I'll conclude my talk. So AI workloads, this invention of these large language models puts a tremendous pressure on networking because these large models runs on like thousands, tens of thousands of GPUs. They are very high-speed GPUs, and they run like training, especially the training runs for weeks, even months, to train a large language model. And for that, we need very low latency, high bandwidth network. And traditional network cannot do that. Although we have networking hardware that's very fast nowadays, but when we connect tens of thousands of GPUs, we don't get that high speed. We get very low performance. So that's the problem. So, but to connect all these like tens of thousands of, even hundreds of thousands of GPU nodes in a network, to build a data center, the common way we use like there are two kind of options. One is this InfiniBand network that's proprietary from NVIDIA that gives like great performance. Everybody says that, and it does work. But they're proprietary and very expensive to build and operate. That's why like the researchers, they are pushing for this open source ITF and IEEE standard, open standard based networking that can give this high performance networking for this AI workloads, right? And they, well, the de facto network topology that we build data centers, it's called the claw topology. It can be 2 stage, 3 stage, depending on the size of the network. It's also known as the fat tree topology. That's the almost everybody uses in data center design. And that gives like, it's called the multipath. That's so between any two nodes, we have multiple paths to go from one node to another node. And that provides this multipath routing in the network layer. So ECMP, equal cost multipath routing that we use, that's given. And this data transmission uses the RDMA, remote direct memory access over, that's what we use. We cannot use TCP because TCP is very slow. It goes through the kernel. So RDMA is used. And this ROCKY, it's the RDMA over Converged Ethernet that we use Ethernet networking technology underneath. So, and we build this RDMA network over that technology. And the another aspect is that everybody uses the cloud model because cloud model gives us this flexibility of using resources efficiently so that we can share and by the multiple tenants, multiple users, run multiple jobs at the same time in the same cluster. That's why the cloud consumption model is important, and that requires this network virtualization, right? And it provides this highly resiliency. That is, if one node fails, we can still use the network if one switch fails or any failures it can handle. That's why cloud model is important to build such network. So I was showing that everybody uses the cloud topology. That's the kind of 2 or 3 stage topology. Here is an example in the diagram. That's the 2-stage cloud topology that servers are connected to the first layer switches. They're called the top of the rack switches.
Sorry to interrupt. Can you run your slides? Because we are stuck on the title slide, actually.
Oh, okay. Sorry. I'd see. Okay, can you see my slide now? Like that?
Yes, sir. Thank you.
Okay, so this is the diagram on the right-hand side that shows a sample example of a 2-stage claw network. It's also called leaf and spine network. So it has 2 layers of switches, leaf layer and spine layer, and they are servers are connected to the leaf layers. There's also TOR, top of the rack switches, and because we want cloud model, that's why servers are connected to 2 switches, not 1 TOR switches, so that if one switch fails, we are still connected to the network. And you can see that there are multiple between leaf and spine switches. So that gives the high bandwidth. So, and then in this network, we use BGP as the routing protocol, and almost everybody uses BGP, although BGP is a border gateway protocol, but everybody uses as the interior gateway protocol and BGP provides ECMP routing. And on top of that, for virtualization, we usually use VXLAN encapsulation. Often uses EVPN, Ethernet Virtual Private Networking, on top of the BGP so that it can run in the cloud settings. So I'll not go into the details of each of the technologies because of the time constraint. So once we build this network, we get ECMP routing. And when we run workload on top of this, like the training workload or inferencing or model tuning workload, although we have very high-speed network, physical network that can support, like in our setup, like we played with like each host with 3.2 terabits per second network bandwidth. So, and the whole network is like hundreds of terabits per second bandwidth physically. But we get like 50, 60% of the bandwidth for the application. What is the problem? Problem is this ECMP routing. So what happens that ECMP computes the hash for a given flow. So when we start a connection to any server, a client connects to a server, whether it uses TCP or Rocky, it doesn't matter. It has headers. Header has the source IP, destination IP, source port number, destination port number, and the protocol ID. ECMP hash function computes the hash, it's a random value, and based on that random path. And because of this randomness, multiple flows can collide. For example, here the 2 flows, red and green, coming up from 2 different hosts, and they go up on a single link because 2 flows collides together. And then if these 2 flows are 200 gig each, the uplink will give us only 100 gig. So you lose 50% immediately. That can happen again and going down, for example, multiple flows coming down from the spine, they can collide together. Same thing can happen even going down to the host. So if even the network is even 3-layer claw, then we will have more these collision points, right? So we are losing bandwidth because of this network hash collisions. So how can we minimize that? This is the result of the randomness. So we want to eliminate or minimize the randomness, right? So here is from the actual run of a workload that in the 16 node servers that we had, like in the leaf and spine cloud topology, we ran a workload, and here's a snapshot that you can see that we have like 4 flows per port we want, but the distribution of flows, you can see that some of the ports are unused, some of the ports get like 10 flows. That's how we lose. And what happens that because this workload runs in a synchronous fashion, step by step in a synchronous fashion, the slowest flow dictates the whole job completion time. That's called the tail latencies. So we get the poor performance because of this collision. So we want to eliminate that. How can we design a network that avoids this problem? So hardware approach. So can we design the network in some different ways so that we can minimize this hash collision problem, right? So we examined different options. One of the options that we found out useful was that if the host-facing network ports are lower speed compared to the spine-facing ports, that means if two flows coming from the host collides, but if the host-facing port is like 100 gig and spine-facing port is 400 gig, they will not lose bandwidth, right? So that way we can tolerate or minimize the collision problems. So that is one option, right? Another option is that, okay, we will use many smaller flows, not big like 100 gig flows, but say we use 10 gig each. That way, if they collide, they will not lose like 200 gig flow collides and we get 50 gig, right? But if two 10 gig flows collide on a 100 gig link, we don't care. It will be delivered at 10 gigs. So that way, by reducing the flow bandwidth from the host, we can improve the performance. That's one option we studied and simulated on Omnest simulator and found out that it gives some good performance, but it doesn't eliminate all the problems. The other option is that we can design, this is called a rail optimized design. This came from NVIDIA. Their recommendation that we use rail optimized design, but their rail optimization is only for the leaf layer, the bottom layer. So they cannot solve that problem in the higher layers. And we do a virtual rail so that we can have this rail optimization, but not physical hardware, but we partition the spines or other switches using virtual routing and forwarding options. That way, we can create virtual rail. That means that paths don't cross each other. The rail, like parallel flows, goes to parallel paths. That way, we can design virtual rail optimized network that gives better performance than this just using different bandwidth links from host to leaf and leaf to spine. And here's the simulation results from that if we use same bandwidth at the host level and spine level, then we lose up to 60% of the bandwidth, depending on the cases, worst case. But if we increase the number of flows, that means we increase the number of flows, minimize the bandwidth of each flow, then we reduce that. Here shows that on the left-hand side is that we lose up to 60% if the links are same bandwidth, that we use 400 gig flow. This was, I think, simulation was 100 gig anyway. It's the same. But if we use like higher bandwidth uplinks, then we minimize that. And if we use more flows, that's the pink color thing, that we minimize this problem of hash collisions. So these are the simulation results. And then we implemented that way our on-prem solutions that we deliver to the customers. That helps with this network design, that you use like two options. One is that use higher bandwidth links in the uplink, and you virtually partition the spines so that we minimize the loss of. Then we looked into the software approach. So the Swiss providers, they provide some functionalities in their switches that we can utilize. For example, dynamic load balancing, that flows can be moved around during the duration of the flow. If one link is busy, some flows can be moved to other links, low utilized link, lower utilized links to average out the bandwidth utilization of different links. We tried that, and that didn't help much. So let me go further. So here is the left column that we use this hardware provided dynamic load balancing. The left column is this baseline ECMP, equal cost multipath. And when the links are, this is on a 3.2 terabits network, for every host. So when the flows stays within the same rack, we get close to like 3 Tbps. But when we cross from one rack to another rack, you see what happens. It goes below 50% throughput. Aggregate throughput, we get like below 50%. That's what happened with the ECMP. Then we enable the dynamic load balancing on the switches. It helps, but yeah, it goes up to like 60% or a little bit higher than 60%. It improves, but 10% maximum help we can get. So this is not very useful. So that was not very helpful. Then we looked into, okay, what if we can minimize this hash collision at the host level? So we came up with that routing strategy that's called end-to-end load balancing router strategy. We programmed the host such a way that eliminates the hash collision at the last layer, host level, because host can control how routes are packets flows are sent from the host to the NIC and receive packets from the switch to the host, right? We implemented that without touching the Swiss fabric switches. That way, we see on the right-hand side column that with DLB included, so we enable DLB and we use this new routing strategy. That way, we improve the performance. Now we can get up to like with again increasing number of flows, 4 flows, we go above 80% of the utilization of the network. So we can achieve, but it's still in the worst case at the line rate, but it helps a lot. So this is one of the options. Then we say, okay, can we do better? So we went back and thought about it again. So we came up with the similar to virtual rail that I mentioned before, that we will program the fabric using this new kind of routing standard called the segment routing. That way we can control the path. It's a source routing strategy. So we kind of bind the links into path end to end, right? And then so flow comes in, we select one path. It doesn't cross at the spine layer or at the destination leaf layer because it's the parallel path we create through the routing using this disjoint source routing, which is the segment routing standard, new standard for routing. We eliminate hash collision at the spine as well as at the destination switch, but we still have hash collision on the left at the source switch where we use DLB, dynamic load balancer. With this, the right-hand column shows this result that we if we use like 4 flows per port, then we can actually go up to 90% or 90 plus percentage of utilization of the network bandwidth. So that's very good and it works very well. But this is a complicated process because it requires multiple protocols and that configuration gets very complex. But still, we lose some performance up to 10% of the network bandwidth we cannot utilize, right? So we thought about it that can we eliminate totally? Then we came up with routing protocol called deterministic routing. So that way, we want to eliminate the randomness of ECMP altogether. So we implement a BGP, program BGP using BGP features that way that we assign prefix for every destination. We assign a path. So we know the paths because it's the fixed network, and the claw has this nice property that it has like fixed number of paths between every pair of the switches. So actually from every host to every other host, it has like fixed number of paths. Like if from one host we have 10 paths, every host has 10 paths. That nice property gives us that, okay, then from every host, if we have 10 flows, we can pin them to 10 different paths, right? That way, but this is a hard to solve this problem in a generalized environment, but we came up with a solution, pre-compute this path, which is relatively expensive, but then once we install, we get this nice property that we have fixed number of flows, fixed number of paths, and we assign each path, well, to a set of flows because we'll have much more flows than the number of paths. In network, we may have like 10, 20, or whatever many paths, which is even better than what InfiniBand provides. That's the best golden standard that in the industry. So, but that was our network testing, benchmark testing. Then we ran actual workload. So what do we get? So this is the results of all reduced operation that's the most expensive operation language models use, right? And you see the problem that even with the 16 QP is the term RDMA terms, which is actually flows in the TCP flow concept. So as we increase the amount of data, the block size like 8K, 8 gigabyte per flow, then we lose performance, right? But for our different routing protocols that we developed over time, you see that the baseline is simply there's the dark blue line. We actually, out of 400 gigabyte, which is 3.2 terabits per second, we actually get less than 150 gigabyte throughput for the actual application workload. But when we use determined that we developed in ourselves, that gives us like over 350 gigabytes per second throughput for every host in the network. So that is like the kind of practical max you can get out of 400 gigabytes of bandwidth. And the other solutions that we discussed, they get in between something, so that the virtual rail we mentioned, that's the orange or yellow one, golden one, that gets closer to deterministic, but it is lower. So in conclusion, we can say that the ECMP is the main problem in this AI network, because this AI workload, large language model, they don't like this randomness. And the existing solutions, they cannot handle that. We do not have. So we developed this deterministic routing protocol that resolves this ECMP hash problem in a claw network, where we can run this AI workload and get the best performance using the non-proprietary software solution. And here are the papers that we published on this work, and you can find them on the IEEE or ACM portals. Thank you.
Presentation. Dear audience, do you have any question? Yes, we have.
AI workload, right? They use RDMA. That's the main difference, that traditional data centers, most application use TCP or UDP as their protocol, transport protocol. But AI workloads, they cannot use TCP or UDP because TCP UDP is very slow. So you have to use remote direct memory access protocol, and that's that only like the proprietary InfiniBand network that natively supports, because they developed that RDMA protocols, right? But this open standard that IEEE and IETF, they worked to bring that RDMA technology networks. So this requires special network interface cards that are RDMA capable. And nowadays, like I think all the network vendors build NICs that supports RDMA. So yes, that's the main difference, that it has to support RDMA. Other than that, the network, because as I said, that claw network is the standard nowadays, like almost everybody uses claw topology, leaf and spine or fat tree topology, and use BGP as their routing protocol. So almost everything is converged except this RDMA versus TCP UDP. Cloud is mostly TCP UDP, but AI needs RDMA.
I have another question. Is
Sure.
the definition of an AI data center strictly tied to hardware, or does so specialized software-defined infrastructure?
Yes, good question. So the thing is, like AI data centers, right? You need GPUs, right? You cannot run RDMA capable NICs, right? And the GPUs and the switches that understands this Rocky, and you configure them accordingly. So this is slightly different than traditional data center where you don't care about RDMA much, or you don't care about this Rocky protocol, right? You don't enable Rocky. So this requires additional configurations on the switches and on the hosts, and also in.
Thank you, sir, for giving us your valuable time. We are now going to conclude this session.
Thank you.
We are already 30 minutes late. Thank you. Thank you so much, sir.
Thank you everyone for being with us, and I'm extremely sorry that our session is delayed for some time. But right now, I would like to request